Hi everybody, welcome back. So this next topic is going to be about systems of equations. This first lesson is going to be rather short, just really discussing what a system of equations is, and then the next two lessons will discuss how we're going to try and solve them. In this lesson, we're not really going to do much that you don't already know, so it'll more be kind of a review while introducing a next topic. So first of all, what is a system of equations? A system of equations is a set of two or more equations with the same variables. Now I want to add in something else here. I want to circle this one part, solution. We discussed in the last lesson what a solution is. Solution is where the two or more lines, we're only going to deal with two lines for this lesson, where the two lines will intersect. And we also discussed this when we were looking at parallel versus perpendicular lines, the solution possibilities. We have one unique solution, as shown here, which can also include perpendicular lines, but we don't really need to know that. Oh, side note, this is the symbol for perpendicular, and then this is a symbol for parallel. I forgot if I mentioned that last lesson or not, but it's something you should know. Okay, so this can also include perpendicular lines here with one unique solution. This isn't necessarily, but it can be included. Next, we have the no solution one, which is parallel. They will never meet. Then we have all real solutions, meaning at every single point on both of these lines will be a solution since they are the same line. All real solutions, or also known, as we mentioned, infinitely many solutions. That's the number of solutions. This is the number of solutions, and this is what those solutions are. Fantastic. So for now, we're only going to do two mini questions about solving the system of equations graphically. All that means is you're basically going to graph the two equations to figure out the solution just by seeing about where they intersect. Later on, I'll show you guys in the next videos on how to solve them without having to graph whatsoever. So let's get graphing. We're going to have negative y equals negative x plus 3. Now we're going to remember to divide by our secret 1, divided by our secret negative 1, to get over here y equals x minus 3. Fantastic. Looks like I didn't draw this axis well, so I'll go back and redraw that in a bit. Now over here we're going to have to subtract by x on each side. Minus x, what is that? Okay, minus x. Whoa, this is getting trippy. Hold on, sorry guys. Y equals negative x plus 5. Okay, let's redraw an axis better now. Draw an axis. Then we're going to plot our points. So, minus 3. Minus 3 over here. Then we're going to go up 1, over 1, up 1, over 1, all the way through. Then over here at 5, 1, 2, 3, 4, 5, going down 1, down 1, down 1, over 1, down 1, over 1, all the way through. And from here, we can see that our solution is right here at the point 1, 2, 3, 4, 4, 1. This is our solution. We can always check our solution by going back and plugging in our numbers into both of the equations and seeing if they fit both of the equations correctly. So we can do that right now if you want. 4 minus 1 does indeed equal 3 for the first equation, check. Then we have 1 plus 4 does indeed equal 5 for the next, check. Fantastic. Let us keep going. Here, I again didn't make these axes well. I apologize, guys. So let's just erase that. We already have our equation made for this one. Now let's go and fix our equation for this one. You have negative 3y equals negative 4x plus 18. Divide by negative 3. Divide by negative 3. Y equals 4/3 x minus 6. Fantastic. So let's draw some axes. Drawing some axes. Okay, first equation we have negative 1, and we're going to be going down 1 over 3. down 1 over 3, like so. So it'll look something like that. Then the next one is negative 6. So 1, 2, 3, 4, 5, 6. Up 4, up 1, 2, 3, 4 over 3. Here's our point. Something like that. So our point is going to be 3, comma, negative 2. And again, we can plug this back into check, but I think you guys get the point. So to get into the real meat and potatoes of solving systems equations without having to graph, and really how you're going to practically use it most often, tune into our next videos, which we're going to be talking about substitution, and then after that we'll be talking about elimination. These are really important methods. So I will see you guys then.